Welcome everybody to the second to last video of this course. It might not actually be the last video depending on what year you're taking this course, but for right now we are in the octa system and this is our second to last video. So anyways, let's dive in. So we did work and energy and power, and now we are going to look at efficiency. So efficiency is the measure of how much of the energy that goes into a machine actually gets used. So machines are useful because they allow us, I'll explain a lot of this more once we get these definitions and stuff in. Machines are useful because they allow us to use less force over greater distances to do the same work. So whenever work is done, some energy is converted into heat. And so because of this, sorry, I'm just trying to figure out here. Because of this, machines aren't 100% efficient. So there's going to be less work out than work in. So you can think of it as this: work into a machine will be greater than work out of a machine. So work in is total energy supplied to the machine, and work out is amount of energy actually used. It'll make more sense once we get into some problems here, but just remember that your work in should be greater than your work out. So the formula is efficiency. So EFF for efficiency is equal to work out over work in, and then we will multiply that by 100 to get our percentage. So it's always expressed as a ratio or as a percent. We can also, instead of using work, if we know powers, we can do the same thing but with power. So power out over power in, and then multiply by 100 to get percentage. So there's no units for efficiency. Obviously, if it's work over work, then those are going to cancel, or power over power, those are going to cancel. But we will express it as a percent or as a ratio. Just a reminder, this one should be the smaller number, and this one should be the larger number. We can't have a machine that's more than 100% efficient. Again, with this one, smaller number, and this should be the larger number. So let's do a practice problem. I think, just the one practice problem. We'll do lots in class. So it says here, a lever is used to lift a 50 kilogram object 10 centimeters. To do this, we must apply a force of 75 newtons to the end of the lever, which displaces 1 meter. Find the efficiency of the lever. So let's draw this for right now. We have a lever and we have a mass, and the mass is 50 kilograms. And we are going to push down on this end of the lever, causing this one to raise by 10 centimeters or 0.1 meter. On the left side here, we are applying a force of 75 newtons, and we are going to displace that by 1 meter. So let's look at the work in. So the work that we're putting in is on this side of the lever. So we can use, we have a force and we have a distance. So we can use force times distance, and that will be 75 multiplied by 1, which is 75 joules. That's our work in. Our work out, hang on, let me label that correctly. You can use two different formulas. Either one will work. You can use the change in potential energy because we are lifting this mass up off the floor, or you can use force times distance, and in this case, the force that we are overcoming is force of gravity. They're both going to end up with, change in EP is EP final minus EP initial, where EP initial is 0. So this will be just EP final, which is mgh, and force of gravity times displacement is going to be mg displacement. Height and displacement are going to be the same thing. So you can use either one of those to solve this. And if we do that, we will get mass was 50 multiplied by gravity, which is 9.81, multiplied by the height, which is 0.1. And we get, I've got my calculator this time, I'm on it. 50 times 9.81 times 0.1. We get 49.05 joules. So our work in is 75, our work out is 45, and we want to find the efficiency. So efficiency is work out over work in and multiplied by 100. So that will be work out is 49.05. Work in 75 joules. And then we want it as a percentage, so we'll multiply it by 100. And we get an efficiency of 65.4%. So we are only using 65.4% of the energy put in to push that far side of the lever, and we're going to move that mass 0.1 meters. Hopefully that makes sense. We will look at some problems that involve power rather than work, but you can still use your efficiency is equal to power out over power in formula. Cool. Thank you for watching. Don't forget to like and subscribe.